Hey everyone, welcome back to my channel. Today I'm going to show you how to add a second NSX-T Edge Node to your environment, how to add redundancy by using an active-active T0, using ECNP routing with BGP. So in my previous videos I kind of explained the fundamentals of NSX-T and how I initially set up my Homelab environment, and now I'm basically just adding redundancy because in any production environment you wouldn't want to run your NSX-T environment on single edges, on single points of failure, etc. So just like in my other videos, I first want to dive into a simple drawing to show you the topology, and then we're going to dive into the Homelab and see how things are configured. A second top of rack router. So I now have two VyOS appliances configured in my environment, and they are connected to two edge nodes. And these edge nodes are both connected to two uplink VLANs. So that's the blue VLAN, VLAN 12, and the red VLAN, which is VLAN 11. And as you can see, I now have fully redundant paths to both my top of racks. I'm going to show you the config of the top of racks as well. But before we dive into the entire configuration, it's really important to understand the difference between an NSX-T Edge and an NSX for vSphere Edge. They both share the same name, but they are entirely different entities, different constructs. And for me, coming from an NSX-V background, this is the most confusing part of NSX-T, to be honest. Because here my T0 router, that's running on both these edge nodes. And these edge nodes are simply transport nodes, just like your ESXi hosts are transport nodes. Only they have an uplink to the physical network, so to the top of racks over here. Connected to the T0 router is of course a tier 1 router, which I drew like a rectangle, and that's distributed across my three transport nodes, my three ESXi nodes. The backend plumbing is done automatically by NSX-T, so there's already a subnet with IP addresses configured. It's a /31, and connected to my T1s are 3 segments for web, application, and my database service. Okay, so let's switch to the Homelab environment and see how things are configured. And before we dive into the NSX-T configuration, I wanted to show you how I deployed my NSX-T edges. Just to save a bit of performance, I'm not doing virtualization in virtualization. So I'm not running my NSX-T edges on top of my nested ESXi host, but I'm running them directly on my physical server. So this is just basic virtualization. And if you look at my NSX-T edges, they are virtual machines deployed by an OVA. And if you look at the network configuration, then you can see that an edge node comes with 4 network adapters, so 4 NICs. NIC number 1 is connected to my management network, which is VLAN 10. Network adapter 2 is connected to the overlay VLAN. So that's used to transport the Geneva traffic. And the adapters 3 and 4, they are used to connect from the edges to the top of rack, so the uplink VLANs. As you can see here, I've connected them to the port group for nested ESXi, which is basically a port group for that makes it a trunk port in VLAN 4095 to 4095. Check out my previous video to see a bit more explanation on setting up trunking in nested ESXi environments. But I'm going to do VLAN tagging inside of NSX-T on the segments. I'll show you that in a bit. But these 4 network adapters are being used in my uplink profiles, which are configured in NSX-T, of course. So let's first switch to the fabric configuration. So let's switch to system. Fabric, and first let's check out the all the edge nodes and the transport nodes. So I have, let me see, so I have 3 ESXi hosts configured for NSX-T. So these are all 3 configured as host transport nodes. So these are my NSX-T edges, and before we dive into the configuration, let's first take a look at the edge uplink profiles. Again, this is pretty confusing, pretty tough stuff to wrap your head around, but first let's take a look at a default edge uplink profile which is already configured, and it's really basic. It's called NSX Edge Single NIC Uplink Profile, and it does exactly that. It just configures a single uplink to be used, a single active uplink to be used on an NSX-T switch connecting the NSX-T edges. I configured a different edge uplink profile because I want redundancy from my NSX-T edges to my top of rack. So I need 2 interfaces there, one for VLAN 11, one for VLAN 12. And as you can see here, I configured a uplink profile with 2 uplinks, so 2 active uplinks, uplink 1 and uplink 2. Now, looking at the configuration of the NSX-T Edge transport nodes, you'll see that I used both these uplink profiles to create a configuration of my NSX-T edges. So first I added a NSX-T switch within the transport zone for overlay networking, and I used the single NIC uplink profile which I showed earlier. This is only to connect the NSX-T Edge node into the VLAN that's used to transport the overlay network. So let's switch back to my drawing. The only thing that I'm configuring here is, let's change to color purple. I configured a uplink profile so I can connect these 2 edges to the VLAN 6, which is used to transport the overlay traffic, so the Geneva traffic. Now I'm running NSX-T 3.1, and that allows me to use the same VLAN for both my NSX-T Edge transport nodes and the ESXi host transport nodes. In previous versions, you were required to create separate routable VLANs for both your edges and both your transport nodes. So with 3.1, I can just put my edge nodes and my ESXi servers in the same VLAN. So if I would draw that into this, I'm just going to do a big simple drawing. If I were to connect or draw my NSX or ESX host in here, I would just simply put the tap interface of the ESXi server in the same VLAN as the tap interfaces of the edge nodes. And that's pretty important to remember with version 3.1 and previous versions. So let's switch back to the configuration of the NSX-T edge nodes. So a single vSwitch connected to the overlay transport zone using the single NIC uplink profile. I've used an IP pool to configure IP addresses on the tap interfaces, and I'm just using a single uplink. And here you can see that my single uplink is mapped to the virtual NIC FP-ETH0, and you can see it shows up the MAC address here for this edge node, so it validates the entry. Okay, now let's switch back to the iPad and see the configuration of the network interfaces of an edge node. As you can see here, each edge node has 4 network interfaces configured. ETH0 is connected, or its purpose is to connect it for management purposes. So this is connected to my management VLAN 10. FP-ETH0 is used for overlay networking, so that's connected to my overlay VLAN 6. And then again, FP-ETH1 and FP-ETH2 are both connected to VLANs 11 and 12 respectively, so they can take care of the uplink profiles. So If we look at the configuration of the Edge node once more, you'll see how this maps out. So network adapter 1 was ETH0 connected to management, NIC 2 connected to the overlay network, and NICs 3 and 4 are used for uplink, for the uplinks to my top of racks. Now that was the first switch I configured in NSX-T, so NVDS overlay. The second switch I added is called uplinks, and that's connected to the transport zone, the TZ VLAN uplinks. So that's a VLAN transport zone and not an overlay transport zone. I use the Edge Uplink Profile, which I showed earlier, which has the two uplinks configured, and these map out to FP-ETH1 and FP-ETH2. Alright, so this is the configuration of the edges. Now let's take a look at two segments that I configured to connect the edges to my top of racks. These are segments within the VLAN transport zone, and here you can see that segment 1 is configured with VLAN 11 and segment 2 is configured with VLAN 12. And this way I can, so this is VLAN 12. So this way I can do the VLAN tagging inside of NSX-T. The NICs on the edges are connected to my nested ESXi port group. So the nested ESXi port group is configured using VLAN 4095. So again, I can do the VLAN tagging inside of NSX-T. So let's take a look at the port group. The nested ESXi switch. And here I have a nested ESXi port group with VLAN ID 4095. So this is how I basically connect my NSX-T T0 router using the edges to my physical network running connected to two top of racks running VyOS. Now with all the plumbing in place, let's take a look at the configuration of the tier 0 router, so the T0. Now this is the topology. So I have 4 active uplinks from my T0. The back plumbing is handled by NSX-T, connecting to the tier 1, and the tier 1 is the gateway for my 3 segments. This is basically a really simple setup, and it's using active-active HA mode. So I'm using all uplinks redundantly. I configured 4 interfaces. So Edge 1, uplink 1 is connected to VLAN 11. Edge 2, uplink 2 is also connected to VLAN 11. And I have the 2 other uplinks. And this basically gives me 4 active paths. So let's again switch back to the iPad. I have VLAN 11, which is the red VLAN in my diagram, configured with 0.2 IP address. I have 0.3 on the other side. So this interface is bound to Edge Node 1. This interface is bound to Edge Node 2. And the blue VLAN is VLAN 12. And I did the same topology. So this gives me 4 paths usable for BGP routing. These are being used to establish the BGP neighbor relationship between my T0 and my top of racks. So I configured a local AS number of 65003 on NSX-T, and on my VyOS routers, so my top of racks, the local AS number there is 65001. So I'm using ECMP routing, as I mentioned earlier, and I configured 2 BGP neighbors. So from the NSX-T perspective, I have 2 neighbor relationships with my top of racks, which is in VLAN 11, so the red VLAN, and VLAN 12. And the basic configuration is really simple. You just put in the remote AS number. So again, 65001 is the local AS number of my VyOS routers, and in a neighbor relationship you just configure the remote AS number. I enabled BFD, so to do failure detection of uplinks, and I lowered the hold down timer and the keep alive timers, just to make sure that when I'm testing failovers I don't have to wait a minute. So the hold down timer is 12 seconds and the keep alive timer set to 4 seconds, and this is basically the configuration I did for both my BGP neighbors. Now if we're going to take a look at the configuration of the top of racks, first let's show you the config. So my configuration starts with the configuration of my first hop routing redundancy protocol. I use VRRP, which is basically an active standby failover mechanism for default gateways. So for each of my routable VLANs, I configured VRRP, and it's basically really simple. You just set up, the source address for the hellos, which are exchanged. You configure the interface, a peer address, in which, of course, the hellos are being exchanged. And what it basically does is it presents a virtual default gateway to the rest of the network, and on the back end, both routers are taking an active-passive role in routing, and the priority determines which one is active. So the higher the priority number, that's the one that's actively doing the routing. So in my configuration, let's show you the configuration of the second router. And here you'll see that I'm using priority 100 on the number 2 and priority 200 on my first router. So basically the first router is now actively doing the routing. I configured the interfaces, of course, which were already in place. I have now configured VLAN 11, which is the red VLAN, on the first router, and I've configured show config, and I configured VLAN 12 on the top right router, which is connected to the blue VLAN. And I'm using that VLAN, that interface, to do the BGP peering. So if you look at the configuration here, I'm going to skip the BFD configuration for now. Let's focus on BGP first. So the command is set protocols BGP, then the local AS number, so 65001, and then I'm doing the neighbor relationships. So over VLAN 11, I'm connecting to both my NSX-T edges. So 11.2 is a neighbor ID and 11.3 is a neighbor ID. You put in the remote AS number. The timers need to be in sync, of course. So again, 12 seconds for the hold down timer, 4 seconds for the keep alive, and you configure a router ID. If you look at the BGP configuration on the second top of rack, that's basically the same, but it's using VLAN 12, so the blue VLAN, to establish the BGP neighbor relationships. Speaking of which, BGP summary. Here you can see that I have 2 BGP neighbors established, and I have 2 BGP neighbors, BGP summary, and I have 2 neighbors established on the right hand side. Now if we take a look at a bit more detail, IP BGP neighbors, let's take the first one. You'll see that it's established, and that's the BGP state that you're looking for. Anything else, so active or connecting or any other state, then you have most likely a misconfiguration or a misalignment of parameters, because if the VLAN is active, you configure BGP correctly with all the parameters in place, then it needs to go to the established state. Now looking at the routing table, you'll see that for each of my segments, so 100, 101 and 102 are my web, app and database segments. They are reachable over two routes. So there are two routes in the routing table with an equal cost. So traffic will be balanced evenly, will be routed evenly across these links. And the same goes, of course, for the second router, which also has two routes per destination in place. So that makes, over VLAN 11 and over VLAN 12, that makes 4 active links in place. So if we look at the topology again in NSX-T, then you'll see the 4 uplinks in place here. Now that's basically the NSX-T T0 configuration. Now let's briefly look at the T1. Now the T1 is only configured for distributed routing, so I don't need to use stateful services right now. So I'm not configuring an edge cluster for this T1. It's only doing distributed routing right now, which is being done inside of the ESXi transport nodes, so the host transport nodes. So no service interface is configured, it's just distributed routing. And I'm doing route advertisements of my static routes and my connected segments so that my 3 segments are properly advertised to the rest of the network. Yeah, so that's basically it. Let's switch back once more to the iPad just to finish up and see the entire topology for the final time. So I showed you how to configure your 2 VyOS routers. The red VLAN is connected to both edge nodes, and the blue VLAN on the second router is also connected to edge node. So that gives 4 active uplinks combined with ECMP routing that delivers 4 active redundant paths where traffic will be balanced equally. The 2 edge nodes, I showed you how the interfaces are configured on the edge nodes, how to do the configure your uplink profiles, which interfaces are actually connected, to which port group on your physical box. I showed you the plumbing into the T1 router, and the T1 router is doing distributed routing for each of my segments. So yeah, that's basically it for this video. Thank you so much for watching. Yeah, if you haven't done so already, please subscribe to my channel. I'm really grateful of all the nice messages that I'm receiving about my videos. I hope it's helpful and helping everyone out there, understanding NSX-T a bit better. If you were looking for a specific topic which you want me to cover, please also let me know in the comments as well. And yeah, hopefully see you next time. Thanks for watching. Cheers.